In this segment, we're going to talk about rotation transformations, and we're going to look at those on the Cartesian plane. So initially I have my shape here, this kind of a flag looking shape, and it's going to be rotating around point A here at the origin of my Cartesian plane. Down here on the bottom right I can show what angle I want to change it to, what I want to rotate around. So I'm going to rotate it to 90 degrees, as you can see here. FGH is at 90 degrees, so my picture is now rotated 90 degrees. So now I'm going to have the computer show the points. So point A is still at point A. Point B, which was up here, is now over here. And point B was up 2 and over 1, but since I've rotated 90 degrees, and we've seen that rotation, here it is again, I've rotated it, there they are, the pieces. A is at A, B and B prime, C and C prime, D and D prime, and E prime. As I rotate it so that it's 90 degrees, thereabouts, we can see that my shape has been moved over, and it was up 2 and over 1, but I've rotated over to the left here. So I go up 2, or to the left 2 now, and up 1. So it's still up 2 and over 1, up 2 and over 1 to get to point B. To get to point C in my original diagram, I'm up 2 and over 1, 2, 3. Now I go up 2 and over 1, 2, 3. And so I now have a new C prime. So here's C prime. The same thing happening with D. I go up 1 and over 1, 2, 3. And rotated 90 degrees, I go up 1 and over 1, 2, 3 to get to D prime. And the same thing for E prime, up 1 and over 2, up 1 and over 2. If I take a look at my coordinates now, I can take a look at A is still at the same place, but B and B prime have been changed. Reading the coordinates, we can see that point B originally was at 1 over and 2 up, 1 over and 2 up, and now B prime is at negative 2 over and 1 up, because we've shifted over 90 degrees. And you can take a look and see how the other numbers have changed. We can see that the numbers have switched, and for C the numbers have switched, and for D the numbers have switched, and for E the numbers have switched. And now it's over onto the negative side because we switched 90 degrees for this particular picture. If I continue to cause this to transform over to 180 degrees, let me just get that to 180 degrees. Now my picture has flipped over in essence, and so now we have our coordinates in the new quadrant. And I can see my numbers were still 1 and 2. Now it's negative 1 and negative 2. 3 and 2 is negative 3 and negative 2. 3 and 1 is negative 3 and negative 1. And 2 and 1 is negative 2 and negative 1. Because now it's flipped over to the left and it's flipped over again down. So it's the opposite for my x coordinates, and now it's also flipped for my y coordinates as well. So you can see how that rotation around continues to change the coordinates. As I continue to move my angle around to 270 degrees, it was at 90, then it was at 180, now it's at 270. We can see we're at a new 90 degree angle the other way, measuring down below, and the same thing happens that we had before. Our x's and y's are reversed, and my x's are the same number. They're both positives, but my y's have now, instead of being positive numbers going up on my original color, are now negative going down on my prime, or on my translated or transformed or rotated image. And if I continue to rotate it around so it's back to where I started from, all my coordinates are back to where they originally started. So to 90 degrees, we notice that we have a change between our x and our y's. Our x's are the opposite. They were positives, now they're negatives, but my y's are still positives. As I continue to move around to 180 degrees, my x's have been switched and my y's have been switched. So instead of having two positives, I have two negatives. And if I continued around to 270. We notice that my x's are still the same, they're still positives, and my y's have switched. And then bringing it all the way back to where we originally started from, back to 0 degrees, and we're back to where we were originally, and our new translated, rotated image is over top of the original. So my coordinates are back to where I started from. In this video, in this section, I've changed it again. I still have my same original, A, B, C, D, E, and except this time, instead of rotating around my central point here at 0, 0, I'm rotating around this new green point here. And so as I move my item, I can see that I have a new picture. I'm going to change the color of that picture so it's a little easier to see. So here I am at 0. They're sitting on top of one another. And as I rotate it up to 90 degrees, then I switch it over to 180 degrees, and then over to 270 degrees, and then back up to where I originally started from, we get the same kind of motion that we had on the last diagram. Except now everything's moving over because we're not rotating around this central point here, we're moving around this point here. So let's just take a look and see what that does to our coordinates a little bit. So we'll change it to 90 degrees. I'll put in some points there so that we can see them a little bit better. So here we are again. A's line up A prime with A, B prime with B, C prime with C, D, and E. And as I rotate it to my 90-degree point, approximately, there it is, I can see what happens. My E point on my original was 1 above my rotation point. I've turned everything 90 degrees into a counterclockwise direction, so my point E is again 1.1 away from my rotating point. Point C was from my rotating point up 2 and over 1 to the right, and so from this rotating point up 2 and over 1 to the right, I'm getting to my C prime. So everything's staying in equal proportion. It's just been rotated around that item, or that location marked in green. If we look at point A on our original one, it was at 0, 0. Now that it's been rotated around this green point here, it's still 2 away from my rotating point. So it's still 2 away from my rotating point. It's moved around, and so now instead of being at 0, 0, where it was up here, it's now at this location right here at -2, at 2 and -2. It's still 2 over, but now it's down 2. If we look at point E in my original, it was at 2 over and 1 up originally. So here it is here, 2 over and 1 up originally. But as it's moved and rotated around, it's now directly, it was 1 up from my central point that I'm rotating around. So now it's still 1 up from the central point that I'm rotating around. That gives it a new coordinate now. Its new coordinate, sorry for the rounding error, is about 1 and 0. So it's 1 over 0 up. So it's still 1 away from my new rotating point. As I move it to 180 degrees, everything's rotated that much further. Here we are at my original. Here I am at 90. Rotate some more down to 180. And so now we have this kind of a situation. And it's rotated around the green central rotation point. Point E is still 1 away from my rotating point. Originally it was 1 above the rotating point. Now it's 1 below my rotating point. Point D was 1 to the right, and now it's 1 to the left. But if we turn our head upside down, it's still 1 to the right and 1 up. But now it's 1 down. So that rotation is still occurring, along with changes in our coordinate points. And as we continue to turn it around to 270 degrees, we can see that it's moving, it's just rotating around that E point right here in the center, and comes back up to where we originally started from again. We can also talk about rotational symmetry of certain shapes. Here's a nice beautiful diagram that we have here that seems to have something that's being repeated over and over and over again. So I'm going to say that this red circle here is repeated, so I'm just going to show that red segment, and I can see that I have a series of those red segments around here, repeated over and over and over again to make this design. Order of rotation is the number of times a shape fits into itself in one complete turn. Now the shape that we're talking about is this wedge that I've drawn here, and it's this ice cream cone shape of our picture, and it's been done over and over and over a number of times, and the number of times that it's done is 1, 2, 3, 4, 5, 6, 7 times to make our shape, which gives us the second one known as our angle of rotation. It went all the way around, which is 360 degrees, which is this time here. It's done 7 different times, so I'm dividing it by 7. So each time it's turned 51.43, about 51 degrees every single time. So if I take my picture and ask the picture to do something for me, I'm going to ask it to rotate. So I've taken my picture and I want it to transform, I want it to rotate, but it's going to ask how many degrees, and I'm going to use this 51.4 degrees and watch what happens. And it rotates. But the picture still looks the same because it's been repeated over and over again. I'll do it again. I'll ask it to rotate that same 51. So I've done it once. Now I've done it twice. I'm going to do it again. Rotate. Now I've done it 3 times. I rotate again. Now I've done it 4 times. Rotate again. Now I've done it 5 times. Rotate again. Now I've done it 6 times. And if I rotate it again, I should come back to where I started from. Rotate again. And there I am back at the same time. So I've rotated it 7 times, and I'm back to my original shape. This is this angle of rotation, order of rotation. I did it 7 times with a rotation of 51 degrees. But I could also look and I say, well, I see this, that's the big red loops around the outside, but I can also look and see these blue loops along the inside, and there's 1, 2, 3, 4, 5, 6, 7 of those. Does it work for all those as well? And the answer is yes. We've already shown that if I take my original picture and ask it to take my original picture and ask it to rotate, and I'm going to rotate it to 51.4, the blue pieces still stay intact as well, because this whole shape has this rotational symmetry to it. And here I have another picture here that's a Mexican design, and I want to see if you can figure out how many, if it has any rotational symmetry to it. And you can kind of see that there's the 4 quadrants here going across. And if I cut it into its 4 quadrants, we can see that if I was to take this segment here, I'll highlight it, and take that segment and move it over and rotate it 90 degrees, I'll have the exact same picture in this bottom left-hand quadrant, bottom right-hand quadrant, and the bottom right and the top right-hand quadrant. So it has a rotational order of 4. It rotates 4 times to complete itself, and so we can figure that it's going to take 360 divided by 4, which is 90-degree turns, and we can see our 4 quadrants again. So there's a quick lesson on rotations. We talked about it with our coordinates. We've talked with the central point as one piece of our diagram. We've talked about it with a central piece outside of our diagram. We've talked about rotational symmetry with it in the center and it rotating around that center point, which is dead center in the middle of my shape, and coming up with these 2 definitions. And we've also talked about how we might be able to see it if we take a look at a new image.